In my last video, we took this iMac G3 Snow, gave it a cleanup and gave it a fresh install of OS X Panther to confirm it was all working. In this video, we're going to push this as far as Apple ever intended it to go in terms of updates, and then take it that one step further. So stay tuned. And if you enjoy shameless plagiarism of far more successful YouTubers, I hope you'll consider subscribing to the channel. Okay, so that's enough of that. So this iMac G3 is the fastest that Apple ever made, but that's not to say we can't make it even better. For a start, we're going to take the RAM in this machine from the 384 megabytes it currently has, all the way up to a full gigabyte of PC133 SD RAM via these two 512 megabyte sticks which originally came from a Power Mac G4. We're also going to max out the storage to 120 gigabytes, which again is as much as the firmware in this machine will support, and not only that, we're doing it via a SATA SSD of all things. And finally, we're going to replace the stock CD-ROM drive with a DVD rewriter drive from a much later Intel-based iMac. In fact, this drive came from late 2006. That's potentially a whole 7 years newer than the original CD-ROM drive that shipped in some G3 iMacs. How can we possibly fit so much relatively newer hardware into this 25-year-old Mac? Through the joys of 3D printing and adapters, of course. Before we continue, I want to let you know that this video is sponsored by PCBWay. I use PCBWay for all my PCB needs, and the service I've received has always been quick, cheap, and of a high quality. Simply upload your Gerber files and select the options that suit you, and PCBWay will give you an instant quote. They also have a fantastic project library, many of which include a bill of materials so that, if you want to, PCBWay can source the parts to construct a PCB for you. What's more, the project owners are paid a commission each time you order their design, so it's a great way to support independent creators. Order yours today at PCBWay.com. So first of all, we need to remove the bottom cover, and that's easy enough with just 4 screws needing removing from the bottom. And with that out of the way, we just need to remove 6 screws holding down the RF shielding, or at least the ones I'd remember to put back last time. And now everything we need to look at is right here in the middle of the machine. Oh, and thanks to viewer Ty Lexon for pointing out I'd installed the PRAM battery the wrong way around in the last video. Back to the task at hand, and we'll go ahead and remove the cables for the original hard disk and optical drive, and boy is that a challenge. Apple really did pack this stuff in here. I had to go ahead and remove the RAM, which to be fair we're going to be removing anyway, in order to get the IDE cables for the drives out of the way. From here we can just remove the drive cage by removing the 4 screws connecting it to the metal chassis. And with that out of the way, we can then remove the original IDE hard disk and the basic 24-speed CD-ROM drive. Now, as per the last video, I'll be making use of a 3D printed shim to replace the original slot load CD drive with this more recent DVD writer from a later iMac. Both of these devices are IDE, so in theory they should work, but because they're of vastly different sizes, the shim is needed in order to bring the smaller drive up to the right position for the slot in the front of the iMac case. The newer drive just sits into the bracket as so, and then we use 4 M2 screws to hold it in place. And here with it next to the original drive, you can see the slots are more or less in the right place. Brilliant! After that, we just need to mount the original mounting bracket back on, which I'll tell you would be a lot easier if I wasn't already trying to film it. Hang on, let me do this off camera. There we go, looking sharp and ready to drop back in. We just need to attach the adapter to make this a 40-pin IDE connector. Now we're on to a replacement for that loud, clunky hard disk. Originally, this iMac came with this 60GB model, but it'll actually take up to 120GB storage drive. And seeing as this is 2025, we can pick up a 120GB SATA SSD for basically nothing brand new. Of course, this presents two problems. Firstly, this SSD is SATA and not IDE, so we'll need an adapter. I had a good look around online and most forums and Reddit posts seem to suggest that this StarTech adapter should work, so we'll give it a go. This gives us the required 40-pin IDE connector on the rear, though we'll need to use a power adapter to give us a smaller floppy-style Molex connector rather than the larger one the original drive used. The adapter does actually come with the right power cable, but seeing as I also need to use a floppy-style connector for the new optical drive, I picked up this splitter instead, which will do the job just fine. Next, we need to think about the physical size difference. The original hard disk screws into the drive cage using the 4 mounting holes on the bottom, but for this SSD we can only hope to have one of these holes line up, and that's just not cricket. Thankfully, there's a great 3D print model on Thingiverse from Mindrust UK, which does exactly what we need it to. We just fit the adapter to the SSD and position it thusly in the bottom half, and then the top half slides over the top with a little bit of a wiggle, and we can secure the two halves together with a couple of screws. Then we just use the 4 mounting holes on the underside of the caddy to secure the hard disk into the drive cage, which I'm making look a lot harder than it needs to be because I didn't have the right type of screws to hand, so I'm just ramming in some M3s. And with that, we're ready to get the optical drive secured in place as well and screwed into the cage, and oh, balls. Okay, I spoke too soon. The 3D printed mount for the SSD is slightly too tall to allow the optical drive to sit where it needs to. But no worries, it's just a case of opening the original model in Tinkercad and slicing off the top 3mm before importing that into my printer's slicing software and sending it over to the printer. Next morning, I swapped out the top piece of the SSD enclosure, and now the optical drive screws into place with no issues at all. Brilliant. Before I drop the drive cage back in, I'll go ahead and connect up the IDE cable to both drives and connect them both to the power cable via the Y splitter. And then I just need to drop the drive cage back in and connect the IDE cables to the logic board. And with that done, we just need to install our new RAM sticks and we're ready to go. Okay, so obviously we have no OS installed on our new SSD, so I'll go ahead and insert a completely genuine OS X Tiger DVD and see what happens. Okay, so as you can see, we do have a working OS X installation on this Mac, but before I take you through how it performs, I want to just cover off a couple of things because this wasn't as easy as I had hoped. The first thing I want to mention is that this Mac didn't play very nicely with the Patriot SSD. This Patriot SSD, which you can see is not in the Mac, this didn't play very well with the StarTech adapter. Now the drive does work, I've tried it in another machine, it's absolutely fine. It just seems to be some sort of incompatibility with the StarTech adapter. So if you were looking to buy this SSD, don't do it if you're looking to do this project. What I did buy was another SSD. It'll be on your screen now and I'll put a link to it in the video description. That SSD does work just fine with the StarTech adapter. Even though it's a 240 gig drive, it's seen as a 128 gig drive, which is awesome. It's just what we wanted to do. Secondly, I just want to cover off that I had a little bit of trouble getting the SSD and the optical drive to behave properly together. And what it boils down to is that the optical drive is designed to always be the master device, and there's no pin headers or anything like that where you can change that. Now thankfully the StarTech adapter does have a pin header where you can change it from being master, cable select or slave, and setting it to slave works absolutely fine. It's not ideal that the main storage drive is your slave device, but at least both devices work together, so it's absolutely fine. And lastly, a quick word to the wise about the CD drive that I used here. It was from a later Apple device. It was actually an iMac Intel 2005 that it came out of. One thing to be aware of is that unlike the original drive that would have been in this machine, it doesn't have a physical eject button embedded in the slot mechanism. So on the earlier drive, you could insert a paper clip and it would eject the drive. There's no such feature on this drive, which does leave software ejection as the only way of getting disks out, which was a bit of a problem if you have no OS on this machine and you go ahead and install a CD that doesn't have a valid image file on. You can't get the thing back out. What I actually had to do was connect this up to a Windows PC, eject the CD, and then make sure the next time around when it was in the machine that I did actually put a valid OS CD in there. Some of you might be tempted to chip into the comments that there's an open firmware command that allows you to eject the CD, but for some reason, I assume because this is a later CD drive, it doesn't work with this Mac. You put the command in, it just says it doesn't recognize the CD drive, so that doesn't work either.
Those issues aside though, everything works great. Our system boots, and you can see from system information that it has the fastest G3 processor and the maximum 1GB of RAM that this system supports. And we can see if we take a look at ATA devices that the SSD is recognised as being a 128GB drive, again, the biggest that this Mac supports. And to test that optical drive, we can just go ahead and play back, I don't know, any old DVD that we have to hand, and yeah, it'll play back just fine. We can also go ahead and burn CDs direct from iTunes, or transfer files to our 20-year-old iPod Nano. So if your car doesn't have Bluetooth or CarPlay, then you're covered.
And what's more, this thing is silent. I mean, listen to this. That was silly. There we go. The only time this makes any noise at all is when it's using the optical drive, and that's fantastic. I mean, we now have an iMac that is so much more than Apple ever intended when they rolled this off the production line in 2001. We've got the fastest G3 processor, we've got the maximum amount of RAM, we've got 128GB SSD, and we've got an optical drive from a much later system. What's not to like?
Thank you for watching this video. If you've enjoyed it, there is a button explicitly for that, and if you want to see more of this kind of content from me, you can subscribe via the button on your screen now. I'd also like to tell you about the Retro Hardware Discord server, where you can join in the conversation with me and other retro hardware YouTubers, and join now via the link on screen or in the video description. Till next time, bye bye.